Hi everyone, my name is Erica with L&L 3D Solutions, and in part 4 of this tutorial video series, we're going over the basics of software, slicing, and G-codes. Let's get started. Before you start printing, you need a 3D model file to send to your printer. 3D models are created using a 3D modeling software like CAD, Computer-Aided Design Software. A few free popular 3D modeling programs available right now are Fusion 360, Blender, and a simpler CAD software option like Tinkercad, a program that almost anyone can use without any prior experience. Numerous sites have emerged over the years as repositories for 3D models. So if you are not yet comfortable designing your own 3D models, there are tons of free or paid models available for download from popular sites like Thingiverse, Printables, My Mini Factory, and Cults 3D. Once you have a model finished or downloaded, it still needs to be prepared using a special kind of software that translates the model into a set of instructions for the printer. These instructions include parameters such as printing speed, temperature, wall thickness, infill percentage, layer height, and many others. The end result is a long list of instructions that the printer will follow to build your model. This instructions file is called a G-code, basically the language of the printer. This whole process is done using a slicing software, also referred to as a slicer. The name is fitting because a slicer cuts 3D models into horizontal 2D layers that will be printed one at a time. More and more slicers are becoming available. Examples of some are Cura, Prusa, and Orca. In this video, we'll be taking a closer look at Prusa. So to start, you can click the Import button and select your file to upload it. After importing your 3D model to the slicer, you can adjust the settings to meet your requirements. On the right hand of the screen, you can see a display area where you can edit the model, hide the view, and set the extruder to use. Towards the top of the screen, we have a toolbar where you can import models, delete, or clear the build plate and arrange the models. And you can copy and paste the models if you're printing duplicates. If you right-click on the model, you can see more ways to manage it, like adding support blockers, filling the bed with copies, adjusting the infill and height, and a wide variety of other options, including deleting the selected model. Now on the left side of the screen, we have another toolbar. This is where we can move the model in any direction of the X, Y, and Z axes. We can also scale the model manually, or in the lower right corner, adjust the percentage shown in inches or millimeters. Back to the toolbar, we can rotate the model in any direction. We can choose which face to place the model. There's an option to cut the model, and you can decide to keep the parts or not, even adding connectors to the cut pieces for easy assembly. There is a Paint on Supports feature which allows you to add supports manually, seam painting to manually adjust the position of seams, an option for multi-material painting, and a measuring tool to check the distance between 2 points. In the top right corner, you can add automatic supports, either everywhere, for support and forces only, or only on the build plate. You can change the density of the model by adjusting the infill percentage, and you can add a brim that prints a first layer surrounding each print for more stability. Here you can also adjust the layer height and filament type. In the upper left corner, you can adjust the settings in more detail. On the Print Settings tab, you can adjust the default settings of layers, infill, skirt and brims, supports, speed, the amount of extruders, and more. Under the filament settings, you can adjust the default settings of your filament and temperature settings for the bed and the nozzle of each extruder. And under the print settings, you can adjust the general settings of your printer, including the position, travel, and limits of your extruders. Once you're satisfied with your model, you can click on Slice Now. This translates all of your instructions into a language the printer can read, a G-code. Before you export your G-code, it will show you the slicing information, including how much filament will be used, the cost, and estimated printing time. In this preview screen, you can see the model layer by layer, and you can add instructions to pause at any layer or even switch extruders. The bottom progress bar shows the position and path of the tool head on the current layer. And that's pretty much the basics of the slicer. So now we can go ahead and export the G-code. You'll notice that the file will automatically be written with its name, print time, layer height, temperature, filament type, and printer name, and it will save as a .gcode file type. You can adjust the name of the file to your preference, and you can save your G-code directly to your printer's SD card or save it on your computer for later. After your file is saved, there is just one more thing to do before you start your first print. Stay tuned for part 5 and the final part of this tutorial video series. We're L&L 3D Solutions. Follow us on all our socials and feel free to reach out if you have any questions. Happy printing!